So in section 7.2, we're going to continue to look at linear systems of equations with two variables. And in this section, we will really look at the method of elimination, trying to eliminate one of the variables and solving for the other, and then substituting back in. We'll look graphically at what different types of solutions you might have, and then we'll just apply this to a couple story problems. So when we use the method of elimination, the idea is that if you had a system that looked like this, if we combine these, if we added these two together, the 3x and the negative 3x would become 0. And so when we add everything else, we would get 3y equals 6. And so then what we could do is we could solve for y and get y equals 2, right? Because if we had 3y equals 6, then y would equal 2. And then we could go back and substitute the 2 in for the y and solve one of the equations for x. So that this box right here kind of takes you through that method of elimination. Set up your system so that one of the variables will be eliminated, solve for the other variable, and then substitute back in for whatever variable was eliminated. So let's look at this first example here. It's set up for us so that way if we were to combine these two equations here, our y's would be eliminated. So if we have 3x plus 5x, we would get 8x. Positive 2y and negative 2y is 0. And then 4 plus 8 is 12. And so we would get x equals 12/8, which is the same thing as x is 3/2. And so then we would need to solve for y, and you could pick either equation to substitute back in for. So I'm just going to use the first one. And since I know x is 3/2, I'm going to substitute 3/2 in. So I have 3 times 3/2 plus 2y equals 4. So I have 9/2 plus 2y equals 4. 2y equals 4 minus 9/2. If you look for that common denominator, that would be the same thing as saying 8/2 minus 9/2. So you would get 2y equals negative 1/2. And when you divide by 2, you would get y equals negative 1/4. So your solution to this equation would be the point when x is 3/2 and y is negative 1/4. That would be where these two lines will intersect. If we look at this next example, if you notice how it's set up, there aren't, just adding them together doesn't automatically eliminate one of your variables. So what I usually do is look to see, could I multiply one of the equations by a constant so that way it would do that. And so here, what I'm going to do is I'm going to multiply this top equation by 3. And if I distribute the 3 to everything, I have 6x plus 3y equals, not plus, equals 3. And so now it's like I'm combining these two equations. And so if I add those two equations together, I get 12x equals 9. Or x equals 9/12, which is 3/4. And then what you can do is substitute back in, right, for x. So in this case, I would have 2 times 3/4 plus y equals 1. I just plugged back into that original equation. Either one will work. So you get, if you simplify this, you get 3/2 plus y equals 1, or y equals 1 minus 3/2, which would mean that y would equal negative 1/2. So your solution, or the point of intersection for these two equations, is 3/4 when x is 3/4 and y is negative 1/2. So when we're looking and comparing two lines, it's possible that the system of equations, or the system of these two lines, there's three possibilities. You could have one solution, right? And one solution would happen if your lines intersect one place. So one solution would look like you just have a set of intersecting lines, and wherever they intersect, that's what you're finding. That's what we did in those first two examples. Two or more solutions would mean that you just have the same line. Right? They just land right on top of each other. And no solutions would mean that you have parallel lines. So if a linear system has two different solutions, or has two or more solutions, then that means that you have an infinite number of solutions because you just have the same line right on top of itself. So every solution will end up being the same. So this is just the little box that takes us through what we talked about. One solution, you have two lines intersecting at one point. Infinitely many solutions, the lines are just exactly the same. And no solutions means that you have parallel lines. So a system where equations is consistent. So if they ask about a consistent system, you would have at least one solution. Inconsistent would be when you have no solution. So inconsistent would be parallel. And consistent would be one solution, or would be when you have the same line on top of itself. So in this example, we have three graphs. So this first graph right here just means you have the same line on top of itself. The next graph, we have parallel lines, and then the third graph, we have one solution. So we need to try to figure out which system goes with which one. So what I look at here is in A. If you looked at A and you just multiplied, or you were to think about taking this bottom equation and dividing it by 2, by dividing it by -2 or multiplying by -1/2. If you distributed that, you would get 2x minus 3y equals -3, right? So those two actually don't end up being the exact same system. I was checking to see if maybe it was the same as that one, which it's not. So if we look at maybe the last one, and again, we do that same thing. What if we multiplied by -1/2? We would get 2x minus 3y equals 3. And if you notice, that's exactly the same as what you had here. So they're the same equation. One was just multiplied by a constant. So this graph right here goes with letter C. And so then what you need to do now for this one, where we have parallel lines, look to see which two will have the same slope. And so if you look at choice A, if you were to put this top equation in slope-intercept form, you would have -3y equals -2x plus 3, and you would have y equals 2/3 x minus 1. And if we were to take this bottom equation and do the same thing and say 6y equals 4x plus 6, so y would equal 4/6 x plus 1, and 4/6 is the same thing as 2/3, but they have different y-intercepts, which means that you have parallel lines. So that would be your choice B for that one, which just means then that this one would be choice, I'm sorry, not choice B. I was getting ahead of myself. This one would be choice A, right? Because we were comparing those two, which means that this last one is choice B, because if you tried to find their slopes, they wouldn't have the same slope, and they're not the same line. So those are just going to be two lines that intersect at one point. And then our story problem. So we have a grocer sells oranges for 75 cents each and grapefruits for $1.05 each. You purchased a mix of 14 oranges and grapefruits and paid $12. How many of each type of fruit did you buy? So we're going to write two equations. And in your two equations, your first equation, let's set a quantity. And then our second equation, let's write a cost or a price equation. right? And our variables in this case will be oranges and grapefruits. So I'm going to use an R for oranges and a G for grapefruits. And so I know that oranges plus grapefruits equals 14, right? Because I bought 14, or the grocer buys 14 oranges and grapefruits. And then if we write our cost equation, we have 75 cents for oranges and $1.05 for grapefruits, and you have a total of $12. So now if we're going to use the process of elimination here, let's eliminate one of the variables. So maybe I'm going to multiply this top equation by negative 0.75. And so if I do that, I still keep this equation right here, and then I have negative 0.75R minus 0.7875. Oh no, I'm just distributing this. So not I was multiplying by the 1.05. So we're going to have minus 0.75G equals, and then when you do 14 times 0.75, you get minus 10.5. And so now these are our two equations. If we combine those together, we get 0.3G equals 1.5. And if you do 1.5 divided by 3, we get that G is 5. So 5 grapefruits. And if you know that you had 14 total, if your oranges plus your 5 grapefruits needed to equal 14, then that would mean that your oranges must be 9. So you would have 9 oranges.